Next manufacturing application is production scheduling. This is also known as aggregate planning. So here we have an order schedule of two different motors for the next 4 months. So there are two products and the demand for 4 months are given. So here, this is the first problem where we have a time element introduced in the modeling. So far, we've been talking about just one period, that's it, 1 month, or just one problem is with respect to time static. So now we have a rolling time plan and we have a 4 month production requirements given. So we have to now develop a production plan. Okay, one way of approaching this is to produce exactly what is needed each month, and there won't be any inventory, but there may be some issues with respect to production capacity available, or other, there may be other costs involved in terms of uh, production cost and so on. Let's look at what other requirements there are. Um, so here, so demand for motors are given here. So let's move to the next page. So there are four different factors that are given here. The first one is company must meet the demand for each of the two products in each of the 4 months. So that means you cannot have a back order. Okay, so you have to be able to meet. So each month you must have sufficient inventory to meet the demand. All right, so there is carrying or holding cost for any inventory left at the end of the month. So this is like in the inventory chapter we talked about holding cost. So at the end of the month, if you have any inventory left, then you have to assess an inventory carrying cost, and that carrying cost is 36 cents for GM3A motor and 26 cents for GM3B motor. Okay, so there is carrying cost. All right. So the company has been able to maintain no layoff policy as it would continue, and it would like to continue that. So which means that this is easier if the labor hours used do not fluctuate too much from month to month. So this is the problem, because if we produce exactly what is demanded, then the labor hours needed will go up and down because the demands are going up and down. So if we keep the labor hours kind of constant or stay within range, so let's see what is the requirement. So it would like it to continue. So this is easier if the labor hours used do not fluctuate from month to month. So maintaining a production schedule that would require from 2240 to 2560 labor hours per month desired. So that means your labor hours needed has to stay in that band. So that's your capacity limit. So you cannot exceed 2560, or you cannot go down below 2240. So that's why you may have to generate, you may in some months, in lean months, you have to produce more than what is needed and carry the inventory so you can use it in months where the demand requires production more than production, such that we end up having to need more than 2560 labor hours. So in such situation, we'll use the inventory to keep the labor hours needed at the limit. Okay, and the labor needed is 1.3 for 3A and 0.9 for 3B. Okay, so with that we can compute how many hours of labor we need, and we need to keep within these two limits. Then there is an additional constraint here with respect to warehouse. So there is room at the end of the month for only 3,300 units of the two motors combined. So we have to look at what will be the total number of inventory that we will have at the end of the month between the two products, and then we have to stay within 3,300. Yeah. And then we are given some costs. Production cost is $20 for A and $15 for B. So we are the cost of carrying cost is given here, and the production cost is given here. And in formulating, it is important to understand how all important factors are related. So how the labor hours per month are calculated. To help with the understanding, try to determine the number of hours used, the number of units left. Well, this is a discussion. Let's go ahead and set the model up in Excel. Okay. The first thing to do is to enter all this information is as input values. Okay. So we have first the order schedule. So that's your demand, customer orders, right? So for these 2 motors and for these 4 months. Okay, so that's the demand. Let's color code that as we go along. Okay. Now ending inventory for April. So the very first requirement is also the company would like to have 450 units of A and 300 units of B in inventory at the end of April. So that is for the ongoing demands for May and June and so on. So we have to make sure that the ending inventories are that. So we need these ending inventories for April. Now carrying cost is 36 cents and 26 cents. So let's enter them as dollars. Okay, so let's format that. Now labor hours required for these two. Okay, we're given labor hours of 1.3 and 0.9. Okay. Now production cost is $20 and $15. Okay, so $20 and $15. Okay, let's format that as dollars. Okay. Cost increase after March. Okay, so here there is an additional here. Okay, the production costs are currently $20 and $15. However, each of these is due to increase by 10% in March as new labor agreement goes into effect. So cost increase after March, and that is for both products, so that's 10%. All right, let's make that into a percentage. Okay, so and then the minimum and the maximum labor hours, so we want to stay within those limits of 2240 and 2560. Okay, so that, and then inventory capacity is 3300. That is for both motors combined. All right, so let's go ahead and color code that and maybe put a border line like that. Okay, so that's our input. We have entered all the input. Next we have to set up the model.